Hey guys, Mr. Decker here. This is Computer Science Discoveries, and we are working on Unit 3, Lesson 20. This time it's a mini project, and we're going to make a simple little side-scroller game where we make a character jump. We're going to learn how to make a scoreboard. We're going to learn how to make a game over screen. We're going to do a lot here in this one lesson. So this is a good one to come back to later in the future when you're working on your unique game. If there's any aspect of this that you want to include in your final game that we make at the end of this unit, this is a really, I emphasize really good lesson that we're going to go through making a side-scroller game. I really want you to make the same game I'm making. The difference in your game and my game is going to be like colors that you use, perhaps the sprites you use are going to be a little different, but by and large, everything else that you do with this, I want to be the same because, we're learning how to make games and we're going to be doing a lot in this lesson that you haven't done before. So bear with me. This is going to be one of those where you are doing what I do, but you can make some changes based on your own creativity and what you want to do with your mini project, as long as it works. Right. So computer science standards for this lesson, we've got create clearly named variables that represent different data types and perform operations on their values. Design and iteratively develop programs that combine control structures, including nested loops and compound conditionals, and decompose problems and subproblems into parts to facilitate the design, implementation, and review of programs. Then finally, systematically test and refine programs using a range of test cases. Our essential question for this one is, how can the new types of sprite movement and collision detection be used to create a game? Well, in our last lesson, we learned how to do collision detection and test our hitboxes or collision boxes, whichever you want to call them. We also learned about using velocity for sprite movement. So be thinking about this question as we go through this lesson and as we're programming. And at the end, when you're finished, don't forget to come back and answer that essential question with 2 to 3 sentences in the text box. Okay, without further ado, let's head over to code.org. I'm already on bubble 1 here. Let's go ahead and move over to bubble 2. Get started here. It says frog jump. This frog jumping game is an example of a side scroller. Side-scrolling games have backgrounds that move across the screen from side to side. In this game, the player uses the up arrow to make the frog jump. The frog must avoid the mushrooms while trying to get the flies. Every fly scores 1 point, and hitting the mushrooms makes the player health go down. When the player health hits 0, the game is over. Play the game a few times and discuss it with your partner. You have already learned all the skills you need to code this game. You'll be making your own side scroller in this mini project. Let's run. And so, I just hit the mushroom, just got the fly, got another fly. So I'm the frog. I'm hitting the up arrow key to jump over the mushrooms and try to collect these flies. Every time I get a fly, my score goes up by 1 point. Every time I hit the mushroom, the collision detection remains, right, the entire time that the frog is touching the mushroom. And my health continuously goes down as it touches the mushroom. If I just glance at it, it just goes down a little bit. If I just let it go down to 0, I get the game over screen. So there are a lot of conditionals involved here, right? If my frog touches the fly, if the frog touches the mushroom, there's variables set up here with the sprites and the scoring system. And yeah, the health, everything. So let's finish. Let's continue. We're going to learn how to do a lot here. So make sure you're paying close attention, going slowly through this so that you understand what's going on and how this code is read and how it works. All right. So it looks like we already have a couple of variables set up for us. So that's nice. I'm going to move me up here. There. So I'm a little more out of the way. There we go. That'll work. That way I can read the directions and I've got full view of my workspace down here. Hi. Haha. Okay. All right. The sample game had a simple background of a blue sky, a white oval cloud, and a brown ground. You can choose to make your background as simple or as complicated as you want. Do this. Find the code comment background and then use the drawing tools to draw your background. Run the program to test the background. All right, so inside our draw loop, we've got our scoreboard already set up. Our health is already set up. Well, that, you know what? That makes things a lot easier for me. I appreciate you, code.org. Come on, do you, man? So health is already set up to 100. But the scoreboard is not set up, so we'll have to get that. We do have a score variable set up outside the draw loop already. Here's the background. So let's go ahead and start making our background. So my background color, I think let's just start it with a navy blue. That didn't work. Let's try dark blue. And remember, you can always go to HTML color names to see what color names you can use in here, and they will work. I will leave that up. But so I want text for my health text to be white. So it shows up a little better on there. Yeah, that shows up a lot better. And use the drawing tools to draw your background. All right, so I'm going to grab a rectangle and I want it to go all the way across the bottom here. So let's see, from Y, or from X, 0. How does this work again? It's been a while since I've used a rectangle block. X, Y, width, height. Okay, so X, 0, Y, let's say 300. Oh, whoops, I'm putting these in the wrong spots. Control Z, X 300. And I want this rectangle to be brown. Reset run. And I want it to go X width of 400. Reset run. There we go. And reset run. And I just want to go back and look at this and see where their ground was. Even lower than that. So let's go back. I'm going to run that again. I'm going to change that Y to, let's see, 350 maybe. That seems more accurate. Sure. Okay. Alrighty. So we've got our background. Let's do some clouds. I'm going to do some gray clouds. It's a kind of a stormy day in my world here. Oh, back to drawing. I don't know why I left. And I need some ellipses for this. I'm going to do a couple of them. And needing to remember how to do this. So X, Y, width, height. So let's put these on the screen first. And I want to change the color of these. Fill color. Every time you use fill, it's going to mess with what's below it. So fill brown there. Now that's yellow because I use fill yellow here for my ellipses. So for my X and Y properties, and I want them to be wider than they are tall. So let's do 250 wide and 100 tall and 200 wide and 72 tall. Just some numbers to see what we get. And then I want to change the X location of these. X location of it to, let's say, instead of right in the middle at 200, we'll do like 75 for one and 300 for the other. Let's leave them at 200Y. Let's move those up. So to move them up, let's do 100 and 75. That works. And I want those to be gray. And I want that to be no fill. Good. I want them to overlap a little bit, so I'm going to move this one a little bit that way. Let's see, 75, 125. Oh, why did I do no fill? I need no stroke there. There we go. Cloudy day. And my health up there is still visible, and there's room to put my score here. So far, so good. All right. So we've got our background in here. Bubble 3 is finished. Bubble 4. Next, create the sprites you will use in your program. You'll need a player, the frog, the target, the fly, and an obstacle, the mushroom. You can make them anything you want. I'm glad you said that, because I am going to make them anything I want. All right, so I'm going to throw away the stuff I'm not using. And in classic Mr. Ecker fashion, I want to import my Decker astronaut. That's going to be the character I play as. I'm going to also use something that I want to catch. School objects. I'm going to catch Chromebooks. And rename this Decker. Make it simple. And then the thing I'm trying to dodge, what am I going to jump over? What am I going to dodge? My background's blue, the ground is brown. I'm trying to make sure that I'm not messing with the colors too much. Do I want to dodge any of these guys? Mummy virus guy? We'll dodge the mummies. All right, so now we've got our 3 sprites here: Decker, Chromebook, and Mummy. All right, so go to the animation tab, make sure that you have all the images that you want. The frog, mushroom, and fly are already there, but you use whatever images you want. Find the code comment, game setup, up here. All right. Create your 3 sprites. So Decker, and let's run it just so it saves. I want Decker to be maybe a little bit further this way. X125. And run. And bring him way, way down to like where he's standing on that. Oh, I need to tell the sprite what to be. And he's way too big. Scale. And he needs to come back up. And I might want to make him a little bit smaller than that, even. 2.5. That's good. That works. And then let's see. $125 is fine. All right. That way I can see things coming at me and have time to react to it. And I like 300 because I like his foot being kind of on the ground a little bit. Okay, then I need to set up my next sprites. So what did I name those other ones? I named him Chromebook. So getting these set up here. And my last sprite, well, let's see what the size of that Chromebook is. Really big, so let's make that a lot smaller. Scale. Chromebook scale 0.5. See what that does. Let's go a little bit smaller. 4. That'll work. And then last but not least, the, what did we call it? Mummy. He's really big, so he needs to have his skull fixed as well. And anytime you set the scale to a decimal point, like 0 point something, that's going to make it smaller. So if I put a 1 there, that's going to be its normal size. If I put a 3 here, it's going to be ginormous, right? 3 times as big as normal. If I say 0.5, that's half its normal size. But I need it to be even smaller than that. The size that you make yours is going to, let's bring it down to the Decker Sprites level at 300. Going to have to be even lower than that. Okay, and I'm going to start him at 400x so that he's starting over here and coming this way. All right. Might make him just 0.2. Well, we can play with these numbers later when we're determining how difficult we want this game to be. All right. And our Chromebook is also going to start over at 400. Oh, whoops, I changed the wrong one. Control Z. I want this to be 400. The X, not the Y. There we go. Oh, did I change? Yep, I changed that back to 25 accidentally. There we go. Now we're back to good sizes. All right, create your 3 sprites, the player, target, and obstacle. Set each one to the animation you chose for it. Scale each one to the size you want. Place them where you want them to be, on or off the screen. Set the starting X velocity of the target and the obstacle. All right, so velocity, and it's going to be X for both. So the velocity for the Chromebook, let's set it to 3. And then our velocity for the mummy, I'm going to make, I've got velocity right here. So I'm going to move that down. That makes sense to put it in a different spot because it's something that I might be changing later. Mummy. And let's set that velocity to 2. Reset run. Oh, I need to do negative to make it move left. All right. And we've got those moving now. We'll play with those numbers later when we're determining how difficult we want this to be, how easy we want it to be, so on and so forth. And let's see. Now that I've got those moving, I want this to be 450. And this to be 450, so they start off the screen and come onto it. That I like. Okay. Set the starting velocity, test your program, the player should be on the screen, and the target and obstacles should start off screen and move across the screen from right to left. Okay, we're doing that. Hint, the obstacle and target sprite should always move at the same speed. Oh, should they now? Should they now? All right, we'll set them both to -3 then. There, now they're moving at the same speed. You only need to set a velocity for each sprite one time. You can do this outside the draw loop, and we did. All right, so far, we're doing good. All right, bubble 5. I'll move me over a little bit, see how we're doing on time. Okay. 24 minutes in. Not terrible. Not terrible. All right, we'll just leave me right there. How's it going? Okay. The up arrow should make the player jump. There are 3 parts to jumping. Jump up when the key is pressed. Go down when you're high enough. And don't fall through the ground. Okay? Do this. Find the code comment jumping. Jumping. Down in the draw loop, line 39 for me. I don't know what line that's going to be for you. But if you're following along, here's the jumping down in the draw loop. And read the 3 comments in that section. Jumping. If the player has reached the ground, stop moving down. Okay. If the player presses the up arrow, start moving up. If the player reaches the top of the jump, start moving down. Okay. All right, so the first one. Add a conditional that checks whether the player has pressed the up key. So let's go to control. If up arrow, if the player presses the up arrow, start moving up. Up key, okay. If the up key is pressed, use the velocity Y property to start the player sprite moving up. All right, sprites, sprite Y, and in world, we need key went down, up, and then decker, oops. Oh wait, no, velocity it wants me to do, right? Velocity Y, so decker Y, and we'll just set a velocity for it. Run, up, oh, it needs to be negative because we're going up. Run, up. All right, he jumps up. I might want him to go a little faster. Let's see what 4 looks like. Okay. Test your code to see whether the sprite goes up when you press the up arrow. Okay, we've done that. Now, add a conditional that uses the sprite's Y property to check whether it is high enough. Okay, so we need another if statement. If the player reaches the top of the jump, so control if, checking math, if it's greater than, or would it be less than on Y? It's less than. If sprite.y, backer.y is less than, where do we want his jump to end? Let's say 125. Yes, I know. Error, I know. Then, if it is far enough up the screen, start the sprite moving back down. So I need to change its velocity to move back down. We'll go at the same speed. So run. Oh, I need to go down. So that needs to be a positive. Let's jump. He comes back down, but he goes down forever. So I need one more if statement. Add a conditional to check whether the sprite is low enough on the screen to be on the ground. All right, so we're probably going to have to play around with some numbers on this one. So if the player has reached the ground, stop moving down. So we're going to check his Y location again. Math. This time it's going to be a greater than sprite drawer, sprite.y, decker.y. Checking to see if his Y is greater than, let's say, 350. And then once we do that, then his velocity Y is going to be 0. Because we don't want him to move anymore. Run it. So we're going to have to be higher than that. So let's try 315. That's it. Higher than that. So let's do 290. Actually, what did we start with? 300. So let's just set it to 300. So he comes back down to the same exact spot every time. Okay, and where did he start? Slightly higher than that, it looks like. So let's try 290. Oh. No, 300 it is. Still seems like he's coming down lower than where he started. So 295. Why is it getting stuck? I guess we'll just leave this at 300 then. It doesn't like 295 or 290. It's a lot more fluid. It's not getting stuck. All right, we'll use that. Okay, we've got our jump working. So finish, continue. So as you can see, it takes a lot of testing to make sure a game works the way you want it to work. All right, looping. Bubble 5, or bubble 6, I'm sorry. Further ahead. The obstacle mushroom and the target fly need to loop back to the right of the screen once they go too far. The obstacle mushroom and the target fly need to loop back to the right of the screen. Okay, I get what you're saying. Each time they get over here, you want to reset them to the right side. So find the code comment that says looping. Where is looping? There you are. All right. And it says if the obstacle has gone off the left-hand side of the screen, move it to the right-hand side of the screen. So we need an if statement. And if the target has gone off the left-hand side of the screen, move it to the right-hand side of the screen. Another if statement. All right. So now, add a conditional that uses the obstacle sprite's X property to check whether it has moved off the screen. Okay. So over here is off. So if its X value is less than, say, and then it's going to be less than on the other one as well. Getting into this. All right. Sprite.x and Sprite.x. I'm going ahead and building both of these out. So for my obstacle, which is the mummy, and my target is the Chromebook. Saving the Chromebooks and avoiding the mummies. That story checks out. Yeah, that's some cool storytelling there. Okay, so if it is less than, let's say, negative 50, and negative 50 for this as well. That way it's all the way off the screen. Because it says if it has moved off the screen, use its X property to put it back on the right side of the screen. Then its X value. So if mummy's X value is less than negative 50, meaning it's all the way over here, then its X value equals 450, right back where it started, right? 1 second, guys. And we're back. Okay, sorry about that. Everyone has tech issues all the time. Okay. Let's see, where were we? 450 is its starting X. So both need to go back to 450. So the Chromebook as well. So sprite.x. So the way this code reads out, if mummy's x value is less than -50, then mummy's x value gets 450. So every time, what that means is every time it goes off the screen over here, it's going to zoop back over here and continue that loop. That's why it's called looping right here. And both objects are doing that. Okay, and test the code to see whether the target is looping. Well, they definitely are, and I can make my little guy jump still. So I'm assuming that on, I can double, triple, quadruple jump as well, apparently. Interesting. Could you do that with the, let me finish that bubble, and I'm going to go back over here and see if I can do that with the frog game. No. What did I do differently, I wonder? Okay, well, maybe it's key went down. Maybe it should be just key down. Well, you still, then I can just continuously, kind of cheapens it, doesn't it? Maybe I need an else here. I'm not going to think too much about it. Let's continue. I might come back to that at the end when I'm doing some more testing. Sprite interactions in the game, in the sample game, the obstacle mushroom rotated and the health decreased when the player frog touched it. The score increased and the target fly moved back to the right of the screen when the player frog touched it. Do this. Let's give ourselves some room to work here. Find the code comment Sprite Interactions. Where is that? Sprite Interactions. Here we go. Sprite Interaction says if the player touches the obstacle, so we know we need an if, the health goes down and the obstacle turns. All right. And if the frog touches the fly, the score goes up and the fly resets. So now we're going to be messing with score. I'm going to have several things inside these if statements. So first, though, we're going to create a conditional that checks whether the player sprite is touching the obstacle sprite. Check a conditional that checks whether the player sprite is touching the obstacle sprite. Is touching. Decker mummy. All right. If they are touching, decrease the health. Okay, so variables. The variable name is health. Variable health equals math decrease health minus, what does it say? If they are touching, decrease the health and change the obstacle sprite in some way. So health -1. Let's run that and make sure that's working. Oh, what's going on? Looks like you left a parameter empty. What did I leave empty? Oh, on this if statement. Sorry. Oh. Line 82. Cannot read property toString of undefined. Well, I've done something wrong somewhere. Health. That's just telling the text to be up there. Oh, the number. Well, health should be 100. Health gets health minus 1. I'll be right back. Let me check on this. All right, I figured out what I did wrong. So, see the var, right? Var up there for health. It's like I'm resetting that over again. So in variables, I just want to do x health equals, not variable health equals, because I've already established there's a variable called health that equals 100 at the beginning of the game. Now I'm just calling that variable again, health equals, and then math health minus 1. So now, there we go. It shows up properly up here, and yes, that's what I want. That looks like it's hitting though before and after. So I'm going to go into Sprites and I'm going to check some stuff. Where's my debug? I don't have sprite.debug on this. Maybe it comes later. But I do know what I can do is here, I can crop this. That makes its hitbox smaller. Crop that and crop this. All right, back into the code, run it. That seems a little better. Oh, the game over screen's already set up too. Okay, well that's good. Makes it a little quicker and easier. All right, create a conditional that checks whether the player sprite is touching the target sprite. Where are we checking that? I think I went past it. There it is. If the frog touches the fly. And this is going to be if the player, I'm just changing this, touches the Chromebook. All right. So to check that, we need an if statement. And sprite is touching. Checker touching Chromebook. Then variable score gets math score plus 1. So let's run that. Oh, we don't have a score showing up though. If they're touching, increase the score and move the target back to the right of the screen. Oh, okay. So we also want, let's see, Sprite. If Decker is touching Chromebook, then Sprite.x Chromebook.x equals 450 again. So let's run that and check it. All right, good. That's working. Reset. Increase the score. So I want my score to show up though. Where is my score showing up? Here's health. Scoreboard. Maybe that comes after this. I am imagining it does. Checking. Move the target back. Run the program, test your code. Decrease the health. Oh, change the obstacle sprite in some way. I forgot to do that. So Where's the looping again? I keep getting there. Okay. No, that's not what I'm checking. It's Sprite Interactions that we're checking here. Is touching mummy. Health goes down, and the mummy needs to change in some way. So if I hit him, I'm going to have him rotate. Or if he hits me, rather. Mummy rotation equals, let's say, 40. Let's see what happens if I do that. All right. I like that. And then I want, but when he gets to the end of the screen and comes back, he's still tilted. So if he's less than 450, yeah, down here under looping, if mummy's x is less than -50, then I want to set his rotation back to 0. So now when he gets to the end, let me jump here. Should, yeah, good. And then it should work if I touch him again that he tilts. Yep. And I want to make another mummy. Call this one mummy 2. And I'm going to change the color of his eyes when we touch. So paint bucket, red. And like a lighter shade of red. There we go. There's mummy 2. So now if I go back to my code, and if we're going to have to do this in 2 places. If Decker is touching mummy, then sprite.set animation mummy to mummy 2. Let's see if that works. Yep. And then we're going to have to change it back to the original mummy each time it gets off the screen. So back down here into looping. Set animation mummy mummy. So let's see. Just testing. He changes and he's back to normal. Good. Excellent. It's working how we intended. All right. Finish. Continue. Scoreboard. Right now the health is displayed, but the score is not. See, I thought that we would be messing with the scoreboard, and we are. Do this. Find the code comment scoreboard. Here's where the score is being set up here as a variable. Scoreboard, scoreboard, scoreboard. There it is, scoreboard. All right. And read the code that makes the health information display. We've looked at that. Add code to create a scoreboard and run the program to test your code. So because our health is over here, we want our scoreboard to be over here. So we're going to keep this similar. So drawing, we're going to use a text block. And we're going to have that say score with a colon in it. And 0.15, where does that show up? Let's bring that down a little. So X, I'm going to bring it over and down. So I want to over to 10 and down to 25. Bring it down even further, get it kind of on the same line as that health. And where is the health text showing up? 30? Let's do 20. All right, I like that. And then to get the score to show up, text, I'm going to take the quotation marks out of there. Make sure I am score all lowercase. The score is that variable name. That's the value. And then to run, see that 0 shows up there. But I want my 0 to be right here. So we're going to have to play with these numbers. So score is showing up at 2030. So I want this to be X. Let's try 70 and 30. All right, we're going to have to go even further out. 100. It's too far. Let's try 85. It's coming back. 80. That's a good spot for it. And let's bring it down just a smidge. Maybe 32. Let's do 31. That looks good. And then let's get a score. And that's working. All right, and I want to score more than 10. I want to get into the double digits just to see. Make sure that that number is far enough out. Okay, good. All right, we've got our score showing up and working. Run the program to test your code. We did. And so here's where that's being drawn. I want this. Control C. Well, we won't worry about that right now. Run a program and test it. We've got our score set up. Our health is set up. Finish. Continue. Bubble 9. Last bubble. What's our time looking like? Can't see it. Oof, this is a long video. Sorry, guys. I know this has gone long. All right, review your game. Now that you've added in all the features, it's time to play your game. Play your game a few times to check for bugs. Look over your project guide to make sure you have not missed anything and make any last changes. All right, I'll be right back. Hey, guys. All right, so sorry about the little pause there. I was trying to figure out how, because when I run this, right, oop, I accidentally hit, I'm going to make, so we're testing stuff. I'm going to make my mummy a little smaller. So go up here to scale, mummy scale, 0.17. That way his jump works a little better. But now see, I can basically cheat in this game, making sure that I never hit the mummy. So I want to fix that problem. Let me go back to animation and make sure that both of these are cropped. Good, yeah, okay. Now, I want to make sure that when I hit jump, it can only jump once. I can't do this double, triple, quadruple jump in the air for all of eternity and basically float. Where's my jumping? Where's looping, drawing, jumping? Okay, here's all my jump code. That's why these comment blocks are important, so we can find what we're looking at. Okay, so we've got where we're checking that if I'm down at 300, then my velocity equals 0, right? So I want to turn this into an else. I'm going to take this code and put it in my if statement up here. So if then, and then pull this and put it in else. And let's run it now. Oh, and you won't jump at all. So maybe if I, because he starts at 300, maybe this needs to be 299. Still broken. Greater than 299. If key down went up, velocity is negative. Else, oh, I see what I'm doing wrong. This needs to be an else. This can stay that way. Now run it. See, now I'm hitting it, and I can only jump if I get back down. Now my game's working. Okay. I like it. All right, so now I just have one jump I can do. And I think we need to slow down how fast he comes back down. So velocity of 3 as he's coming back down. So he kind of floats a little bit on his way back down. That ensures that, oh, you're not getting too much of a penalty. Oh, I'm landing right into him on that one. Ouch. So now, and I want my y to be random between a certain range for when it loops on my Chromebook. So sprites, sprite.y, Chromebook.y equals math, random number, and I'm starting it at, where's my Chromebook? 200. So we'll do something random between 150 and 300. Run. Well, it's still showing up in the same spot, isn't it? Why is that? Oh, now it went up there. Oh, or if, okay, so I need to copy this code, Control C. Because I kept getting it. It never made it over there, so that if statement never became true. So if I'm touching it, let's get my cursor up there. Looping. If Decker is touching Chromebook, Control V. So now let's see. Okay, 300 is a little low, obviously. And I want to change the speed of my Chromebook. I know it said not to, but I'm doing it. I'm going to have it go faster so that it's not in the same spot all the time. Yeah, I like it. So now there's some actual strategy to this. If my jumps are working, score of 20, 23. So I'm doing well at my own game now. This is good. I like it. There's some challenge to it. And I'm just going to let it quit out now. Cool. I like it. Yay. And then looking down here, look at how many lines of code we did. 105 in an hour or so. And I want to go back to this, what the jumping, as this reads out. So if Decker.y is greater than 299, and the reason why I did 299 is because he starts at 300. Why? If I leave that at 300, it breaks the game. Now I can't jump at all. If I make this 299, now he can jump when he has landed, and only when he's landed. So if his y value is greater than 299, he can jump, and that's the only time he can jump, right? If his y value is less than that, he can't jump, and that's how you prevent that double jump from happening. And so if Decker's y value is greater than 299, and if the key went down up, if you hit the up key, so if both of these things are true, then he'll jump up, else his velocity equals 0, and that's how that works. Okay, we've got everything in here. The only last thing I want to do, potentially Control C, and move that down below where all that's being drawn. Let's see if let's score a little bit. Yeah, so now I can see my score, but it still goes up. And my health is still going. But that's what I like. So if you want your score to show up at the end, even on the game over screen, move that those text blocks that you're using to put your score and health on the screen down below where this if statement is that makes the game over screen. And so see, now your player can be like, oh, okay, my score was 10, right? Okay, cool. And I can also do some other things. So if health equals 0, to make sure that the score doesn't change anymore, I can set the velocity of stuff, Chromebook, and the mummy 0. That way the score won't change because those objects aren't moving anymore once the health is 0. So you won't be able to see that, but you'll see it because the score won't change again. So let me just let the mummy kill me. So now my health is going down for, why is the score still just constantly changing? Let me run that again. All right, we got a score of 3. Let the mummy just get me. Well, I thought that would work. If health is less than 0. Oh, velocity Y. There's my problem. So velocity X. Whoops. You guys probably saw that before I did. Now let's run and test. There's lots of debugging I got to do even in my own game. All right, we got a score of 4. Let's have the mummy kill us here. And my score shouldn't change now. Good. Health goes down forever. My score should stay the same. The score's still going up. You guys, mummy and Chromebook. Again, you probably caught that before I did. All right, let's try again. Let's let the mummy kill us. Now my score shouldn't change. Okay. Oy. All right. I can also set the health. So I can go back into variables and say health equals math. We'll just say health equals 0. Let's see if that works. Make sure I score. Okay, that made it easy. Didn't even have to move. Perfect. So now my score stays at 3 and my health stays at 0. Cool. I'm happy with that. Okay, that's the end of it. I'm not changing anything more. I've tested and debugged, and I'm happy with what I've got now. So 114 lines of code to make that little game. Thankfully, some of it was already built out for us. That made it a little bit easier and a little bit faster, believe it or not. Yeah. All right, I'm done. Don't forget to go back and answer the question or the essential question on the, goodness gracious, my brain is programmed out. Don't forget to go back and answer the essential question on the Canvas page for this assignment. Love you guys. Hope you're doing well.